Hello everyone, and welcome to this technical guide. This guide is going to be covering the steps we take to set up Modbus TCP using Cycon. We are going to be using two PLCs that we have here. One will be the slave and one will be the master. Our CM3 SP16 MDR is going to be set up as the slave, and our CM3 SP16 MDCF is going to be set as the master. For the master PLC, though, you will need an expansion called SPO1EET attached to it, and we'll use this in order to be able to communicate to our network. Modbus TCP is a widely used industrial protocol that enables Ethernet-based communication between PLCs and other devices. It allows a master device to read from and write to a slave device using function codes and data registers. So hopefully by the end of this guide, you'll have a better understanding on how to actually use Modbus TCP on your end. So let's go ahead and get into it. So first, we're going to want to open a Cycon program. For this example, we're going to start with the slave first, and then we'll go over how to set up the master. So when you first come into Cycon, you're going to want to go to File, and then click New Project. You'll have an option for a bunch of different modules. For our example, we're going to go ahead and use the PLCS. We'll hit next on this. And here you can see what your CPU type was set to. The CM3 PLCS is what we selected, so that's good. And then the name, you can name it whatever you would like. I'm going to go ahead and just call it our slave PLC. Go ahead and hit OK on that. And then we'll just wait for the project to actually open up. Once the project does open up, we're going to go ahead and just go to our project properties, and then we'll go to a parameter. And within parameter, we're going to select PLC parameter. And then you'll see within PLC parameter, we have a box that appears. There's a bunch of different tabs. For this specifically, we're just going to go into the Ethernet tab. In order for Modbus TCP to function, the slave PLC must have a unique IP address within the network. So the IP address you might see in this example might not work on your network. You just want to make sure you're using an IP that is available for you. So we'll go ahead and just call this one 192.168.1.2.3.3. Subnet mask, you just want to make sure it's 255.255.255.0. Gateway is going to be the same as your IP, except it will have a 1 at the end of it. So we'll go ahead and leave it like this. We'll hit OK. We'll go into Program. We'll right click on it. You'll see an option for a new program. This is going to allow us to select our scan. The scan is a ladder logic program that will allow us to simulate data generation in the slave PLC. So now that we have our scan program open, we can go ahead and create what we want to communicate to the master. So we're going to want an always on condition. For this example, we'll just use F10. F10 is our always on flag. And then we're going to add an increment instruction. So we'll just call it inc. And then we want it to continuously increase the value in registers D0. So we'll put D0. This will simulate a changing value. So this is everything that is needed for our slave PLC. There's not much to it. We'll go ahead and just hit this button right here called link, download, and monitor. Or you can go to the online option and use the link, download, monitor option as well. So we'll go ahead and hit OK on that. Press yes. Hit OK on that. Hit yes. Okay. And as you can see, since it's an always on flag, this value D0 is always going to just keep increasing over and over and over. Just going in a circle. So that should confirm to you that it is downloaded to the PLC. Another way to check is to simply ping the IP address that you gave it, which we have right here. So as you can see, we gave it the same IP, the 192.168.1.2.3.3. As you can see, it's pulling a connection, so that's good. So that means the slave is set up correctly. So now we're going to go ahead and go into the configuring of the master PLC. We're going to recreate the exact same steps that we did before. We'll go to File, New Project, select PLCS. I'm going to call this one Master PLC. We'll hit OK on that. Once the project opens up, we're going to do the same steps as we did with the slave. We're going to go into the parameter first. We'll go to the PLC parameter. We'll go into the Ethernet. And we'll go ahead and set another IP. So this one's going to be different from the slave IP. So it's going to be a similar format. We'll just do 192.168.1, except for the last octet, we're going to go ahead and call this 234. Same thing with the subnet. It's going to be 255.255.255. Gateway is the exact same, 168.1.1. We'll hit OK on that. So now our PLC parameters should be set up. The master PLC is now network ready to communicate with the slave. Next, we're going to establish the Modbus TCP master communication settings, which can be found within Program, New Program, and then if you look under Communication Configuration, there is an option called Modbus TCP master. And hit OK on that. Once this window pops up, we're going to go ahead and hit New. And this is where the IP of the slave is going to be inserted. So we're going to go ahead and put in 192.168.1.233. Port should remain the same, timeouts the same, status code, device is the same as well. So we'll hit OK. Then we'll go down to the bottom left. There is an add option. We'll use this add option to add the function code, so the reading and holding register. We'll hit add. So station number, we didn't change the Modbus station number, it remains 0, so we'll just leave that as 0. For function code, we want to make sure that we're selecting a read and write. We want a read holding register, so we'll go ahead and select function code 3. Start address does not need to change. Data size does not need to change. Device, we are targeting D00. That is our target goal, as that is the value that is constantly being increased. We will also want to ensure that we do not transmit automatically, so we'll go ahead and make sure that's checked because we don't want it just firing off. So we'll hit OK. Alright, and that should be everything that you will need for this Modbus TCP master configuration. So we'll go ahead and hit save on this. You'll also want to make sure that we are targeting slot 1 because that's where our EET module is located. You can go ahead and close that. Now we're going to go back to our program, right click on it, hit new program. We'll go ahead and create another scan for the master. So we'll hit OK on that. Create a couple lines. So first we're going to add a clock 1 second trigger to request periodically just because we don't want it to constantly be firing. So our flag for that is F93, which is a 1 second clock. We're also going to want to make a send instruction to send Modbus requests. So we'll go ahead and put send 1, target this slot, 100. Yep, that should be fine. And then we're going to want to make a comparison instruction. So go ahead and target D00, and then we want the value to be greater than 0. And then we want to close it off with a closed contact, so you can put whatever contact value you want here. And then we'll go ahead and download this to our master PLC, so that way we can see if communication was created. So we'll go ahead and hit link download and monitor to our master PLC, and we'll see if data is actually transmitting between the slave and the master. Once both PLCs are configured and connected, we're going to go ahead and verify that the master PLC successfully reads data from the slave. We're also going to check and make sure that Modbus requests are processed correctly and that the slave register updates in response to the master's request. So as you can see, a connection has been established. Information is pulling from the slave and storing it into D00 on the master. If issues arise, check the network settings, function codes, and memory addresses. But overall, the connection should work with no issues at all. Thank you.